Hello, my name is Joseph Lee. I graduated from UC Berkeley in applied math and physics, and I graduated from UC Irvine with a master's degree in material science and with another master's degree at the University of Southern California in the electrical engineering department. And you can contact me from my berkeley.edu email address. And my father, who graduated from Stanford, the reason why I credited the Berkeley, Caltech, and Stanford basic multiplication method is because my father has taught me how to multiply when I was 5 or 6 years of age, and I got this inspiration in the STEM area, in the science, technology, engineering, math area, by reading the Feynman lecture series at the California Institute of Technology. And Richard Feynman, who got his Ph.D. at Princeton or MIT, was a former professor at Cornell. And now let's begin. So what is 1 times 1, or 1 squared, which gives you a geometry of a um, square, uh, a square dot per se, and 1 times 1 is 1. So you basically have one horizontal line multiplying one vertical line, and you calculate one intersection. So when you draw two vertical lines and two horizontal lines and multiply them out, you get 2 squared, which gives you the geometry of a square, 2 squared, or 2 with the exponential factor of 2, or 2 power by 2. And if you count the number intersection, 1, 1, 2, 3, 4, that gives you a value of 4. And 3 squared, or 3 times 3, which is gives you a shape of a square, a geometry shape of the square. And here you have an exponential factor of 2, or 2 power by 2. And 3 times 3 is equals to 9. And what is 4 times 4, which is 16 if you count the number intersection? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 4 times 4, or 4 squared, is 16. 5 squared, or 5 times 5, gives you, or 5 squared. Again, you have a geometry, a figure of a square, which is 25. 6 times 6, or 6 squared, is 36. And if you see, I basically translated from English to Korean for my Korean audience in South Korea, if they are interested in seeing my multiplication method. I don't know any Japanese or Chinese. That's why I translated in Korean, because that's my other language I know beside English. 7 squared is 49, or 7 times 7 is 49. 8 squared, or 8 times 8. Again, you have the shape of a geometry shape of a square. 8 times 8 is 64. 9 squared, or 9 times 9 is 81, with an exponential factor of 2, or 9 power by 2, which is, if you count the number intersection, that is 81. And you can freeze the YouTube presentation if you don't believe me that 9 times 9 equals 81. And 10 squared is obviously 100, with an exponential factor of 2, or 10 power by 2, which again gives you a figure of a square. And 11 times 11 is 121, which is another example of a square, 11 squared. And the last square I will discuss before is 12 squared, which is 144 in this case. And if you count the number of interception, there's at least 144 interception in this case. Again, here I will start over. What is 1 squared, which is, this gives you a 1 interception. And what is 1 times 2? And 1 times 2 is 2. 1 times 3 is 3. And this time, instead of a square, you have a geometry of a rectangle, which is 3, 4, 5. 1 times 5 is 5. 1 times 6 is 6. 1 times 7 is 7. 1 times 8 is 8. 1 times 9 is 9. 1 times 10 is 10. 1 times 11 is 11. And 1 times 12 is 12. And if you count the number of interceptions, you have 12 intercepts. So if we discuss what is 12, 2 times 1, here you count and it's 2. Here, 2 squared, which is 4, or 2 times 2. And what is 2 times 3? That's 6. And again, you have a geometry of a rectangle. It's 2 times 3 is 6. This is 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 2 times 10 is 20. 2 times 11 is 22. And 2 times 12 is 24. And what is 3 times 1? 3 times 1 is 3. 3 times 2 is 6. Again, you have a geometry of a rectangle. And here we have another geometry of 3 squared, or 3 times 3. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. And 3 times 10 is 30. 3 times 11 is 33. 3 times 12 is 36. And I will pause here and discuss what is 4 times 1 and all the way to 12 times 12 in the next presentation.